The current Node version supports a lot of the modern JavaScript features finalized by ECMAScript. I will be using most of these features, like destructuring and arrow functions, among many others. In this movie, I'll review the features I'll be using in this course. If you're comfortable with ES 2015 and beyond, feel free to skip this movie and jump on to the next chapter. First, let's talk about scopes. Quick trick question. Is this a valid JavaScript line of code? Yes, it is, because these are nested block scope. I can define a variable here and then access it after. In JavaScript, we have a function scope and we have a block scope. The good old function scope gets created every time we define a new function. Block scopes can be simple begin-end curly braces like this, or when used in an if statement or a for statement. The var keyword behaves differently in a function scope and a block scope. A variable defined with var in a function scope can't be accessed outside the scope, while a variable defined with var in a block scope is available outside of that block scope. For example, the I variable that we use in a for loop will continue to exist beyond the scope of the loop, which does not make sense really. This is why in modern JavaScript we have a new keyword to define variables, let. Variables defined with let inside any scope are only accessible inside that scope, making let the ideal solution for the for loop index variable problem. If we use let to initialize the I variable in a for loop, the variable will only be defined inside the for loop. Const is exactly like let, but defines a constant reference for a variable. We can't change the value of a constant reference. If we put a primitive value in a constant, then the value will be protected from getting changed. Note that if the constant is an object, like this one, we can still change the properties of the object, but we can't change the object itself. If we want a completely immutable object, then we'll have to use something else, like object.freeze or immutable.js. Constants are popularly used when importing things from other libraries, so that they don't get changed accidentally. They're also used to define functions because we rarely need to update a function after we define it the first time. Speaking of functions, I think someone on the TC39 committee hates the word function because with the latest ECMAScript features, we can completely avoid typing it. Instead, we can use the new arrow function syntax. The arrow comes after the arguments. The arrow function syntax is even more concise. When the function takes one argument and has one line to return something, we can omit the parentheses, the curly braces, and even the return keyword, and the function will be the same. These one-liner functions are usually used for callbacks in simple map, reduce, filter operations, and functional programming in general. Also, when defining a function as a property on an object, we can use this new shorthand notation, which I really like, even more than the arrow functions. Arrow functions, besides being shorter and more fun to type, are lexically scoped, which is a fancy way of saying that they close over the this keyword available on their parent, while regular functions use the caller to determine what's inside their this keyword. For example, in a Node module, the top level this keyword is the exports object, which is empty by default. I'm adding a property I here just to identify it. In here, I have a util object which defines two functions. F1 is regular scope, F2 is arrow scope. When we normally call F1, the this keyword in F1 will be the caller, which is the util object, while the this keyword in F2 will be the parent scope, which is the exports object. This is a huge benefit when working with closures, and we will be taking advantage of that. When we define an object like X here, and we have other objects, functions, or modules that we want to export as properties on the X object, we can omit the values when the property name and the values are the same, just like this, which is equivalent to the commented version here. When we want to read properties from X and assign them as variables with the same name, we can use the destructure syntax instead of typing the name twice, like this. This is much more impressive when we need to destructure multiple properties from the same object. Without destructure, this line would need to be 3 lines. You'll see me using this pattern to import objects and functions from libraries when I use Node's require function. For example, the React library has a component property. So instead of doing const component equal require react dot component, we can destructure the component out of the require line like this. Destructuring works inside function arguments too. If the argument is an object, instead of having one variable to represent the object, we can destructure the properties that we want from that object into variables available in the function body. Function arguments, including destructured one, also get default values if we don't specify a value for them when we call the function, like this. We can still specify a default value here. We can also use rest parameters to capture the remaining arguments into an array like numbers here, which has the 3 binary numbers left after naming the first base argument. Numbers will be an array thanks to rest parameters. We can also use the 3 dots operator to pass array elements as positional arguments, for example, to clone an array and add elements to it. This is very helpful when we work with immutable objects, and it's also widely popular with React components properties. In this last pattern, we call these 3 dots the spread operator. They can be used to spread values of one array into another array or key value pairs of an object into another object. Modern JavaScript also has a new import-export syntax to replace the require syntax we saw before. This is not yet supported in Node itself, but we can easily get it compiled into what Node understands using a tool like Babel. Finally, while I'm not really a big fan of classes, we're going to use the class syntax to define React components. A class is a wrapper around a constructor function, and we can extend other classes and customize the constructor function when we need to. We'll use this syntax to define stateful React components. There is a lot more features than what I quickly explained here, but those are the ones that we will be mostly using in this course. Alright, time to roll up our sleeves, stop staring at the blank page, and implement our first increment toward a full stack JavaScript application with Node and React.